pose with the fans. Pose with the pose with the pose with the fans. Pose with the pose with the pose with the fans.
Hi everyone, my name is Zarin Nur Ain Binti and my student ID is 2024230374 and I'm from CDCS 1102E.
My name is NurHazlia Dania Binti and my student ID is 2024446314 and I'm from CDCS 102E.
And my name is Nur Aimi Fatini Binti and my student ID is 2024277034 and I'm from CDCS 102E. Today we are going to present technique of differentiation.
For question 1, differentiation in mathematics is a process of finding the derivative or rate of change of function. In contrast to the abstract nature of theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using 3 basic derivatives and 4 rules of operation and a knowledge of how to manipulate function.
Okay, for question 2a, we are given 3x squared sec x plus 2. So I am going to use product rule. So this is the formula of the product rule, which is f prime x equal u v prime plus vu prime. Okay, so let u equals to 3x squared and u prime equal to 6x. So how do I get? So 2 times 3 equal to 6 and x 2 minus 1 equal to x. So in v equal to sec x plus 2, v prime equal to sec x plus 2, tan x plus 2. So I got this from the chain rule. Okay, next I'm write back the formula and I'm going to substitute it back. So u v prime plus vu prime. U I got from here, which is to here 3x squared. V prime from here plus sec x plus 2 from v and 6x from u prime. And the answer is this because I'm going to factorize the 3 and 6x. So that is the answer for question 2a. For question 2b, we are given y equal to 4x plus 2 over cos x. So I am going to use quotient rule. So this is the formula of the quotient rule. F prime x equal to vu prime minus u v prime over v squared. So y equal to 4x plus 2 will be u. Cos x will be v. So u equal to 4x plus 2. When I differentiate, we will get 4 because 4x x 1 minus 1. V equal to cos x and v prime equal to negative sin x, and I got this from basic derivative table. So right now I am going to substitute it back into the formula. V equal to cos x, 4 from u prime minus 4x plus 2 from u, negative sin x from v prime over cos x squared. So I am going to multiply 4 cos x equal to 4 cos x minus will be positive 4x plus 2 sin x over cos 2x. So that's the answer.
For the question number 3, given y in 3x minus 2 to the power of 2x plus 1 minus 10 for y equal to 0, find dy dx using implicit differentiation. For the y in 3x, we're using product rule, which is u v prime plus vu prime. For the u equal to y and for u prime equal to dy over dx, while v equal to in 3x and v prime equal to 1 over x. Where did I get 1 over x, which is from the basic derivative table? So we're gonna cross multiply and get it y times 1 per x plus in 3x times dy over dx. So we're gonna get in 3x dy over dx plus y over x. For the second term, which is e to the power of ex plus 1, for the formula d over dx eu equal to eu times du over dx. For the e 2x plus 1, which is we're gonna make it into the formula and we're gonna get 2e over the power 2x plus 1. For the last term, which is 10 for y, we get the sec squared from the basic derivative table. So 10 for y equal to sec squared for y times 4. The answer is 4 sec 2 for y. So we're gonna combine it all and gonna get in 3x minus 4 sec 2 for y times dy over dx equal to 2e to the power of 2x plus 1 minus y over x. We're gonna factorize it and gonna get dy over dx equal to 2e to the power 2x plus 1 minus y over x over in 3x minus 4 sec 2 for y. And that is our answer.
Okay, for question 4, the first thing we have to do is we have to replace x into 80.99. So that's what we did on the second step. We have replaced root 4x minus 2 over square root of x. From basic algebra, we also know that fourth root can be changed into 1 over 4 and square root can be changed into 1 over 2. But since it's 2 over square root, we also do know that we have to change it into negative 1 over 2. And then right after that, we are going to differentiate. We are going to differentiate 1 over 4 x to the power of 1 over 4, which we're going to get 1 over 4x, and then 1 over 4 minus 1, where we will get negative 3 over 4. For the second equation, we also have to differentiate them, which we're going to get x over 3 over 2. How did we get 3 over 2? We differentiate and minus. So negative 1 over 2 minus 1 is negative 3 over 2. After we have done this calculation, we'll bring it back to its original shape or form, which we're going to get 1 over 4x 3 over 4 minus 1 over x square root of x. So now we have to find the delta x. So how do we find the delta x? Is we take the original value that they have given us from the question, we minus it with the nearest value, which is 81. So we will get negative 0.01. Final step for this question is we have to find fxo plus delta x. We then have to refer back to the original shape or form that they have given. We have to replace x with 81. So as what you can see here, we have replaced it, which is root 4 of 81 plus with 2 over square root of 81. This form is from this shape or form. And then we have to plus it 1 over 4 times 81 to the power of 3 over 4 minus 1 over 81 square root 81. This form is from here. You just have to change the x to 81. And let's not forget, we have to times it with delta x, which is negative 0.01. Using calculator, you will then get the value and you will get 2.77, which they want it in 3 decimal value, which is 2.778. Thank you.
In conclusion, the technique of differentiation are powerful tools in calculus that allows us to find the rate of change of function. For example, in medicine, it can help track the rate at which medicine leaves the bloodstream on how fast a tumor grows.